Notes at the remainder theorem. But first, the remainder theorem says that if a polynomial f of x is divided by a factor, x minus c, then the remainder is the same as the output when you put in x equals c. So to show you that, I wanted to go over two of the problems from what we did today. This would be x equals 2/5. This one would be x equals -1/2, which is what you used when you did synthetic division. And the answer they got for this one was a remainder of 7. So I put that function in my calculator for number 1. You don't have to do this right now, but I put that function in my calculator. So in y sub 1, I have that function. I'm going to put in 2/5. And sure enough, I get the remainder of 7. For this function, which is my y sub 2, I'm going to put in -1/2. That's for y sub 2. So I'm getting 1 for that. And that's what they got for their remainder for that problem when they divided synthetically. Any questions on that? So when I plug in this into the function, I will get the remainder as the answer. Plug this in, the answer to this factor, if you'd set it equal to 0 into this function, I get the answer that is the remainder. So here we have two story problems. The first one says, suppose 800 units of beachfront property have tenants paying $600 per week. Research indicates that for each $10 decrease in rent, 15 more units would be rented. The weekly revenue from rentals is given by this equation, this quadratic equation, where x is the number of $10 decreases the property manager is willing to take. Take the revenue, or find the revenue if the property manager decreases the rent by 50. So what value would I want for x if he's going to decrease it by 50? Should I put 50 in? Yeah. What does x represent? The number of $10 decreases. So if he's going to take a hit of $50, what should I put in as x? 5. And I'm not going to divide synthetically, not with those numbers. So I'm going to do the remainder theorem, and I'll use my calculator for it. I'm going to put in, for y sub 1, -150x squared plus 1,000x plus 480,000. And I put in 5, and I get an answer of $481,250. Would be the revenue if he takes the $50 hit on that, or decreases the rent by that much. Try this for the next problem. This one you actually could divide synthetically. The numbers are quick enough. But go ahead and give that problem a try. 650 tickets is the correct answer. You could have divided synthetically, right? You could have done this and said, all right, I want to know about the 12th game, so I'm going to put 12 in. The factor that would be associated with that would be x minus 12. But x is 12 is what we want to check. Bring down our 1, multiply by 12. Wait, I did something wrong. No, I didn't. No, I did. No, I didn't. 12 times 48, 576. Add them together, 650 is our remainder, and the remainder theorem tells us that that'll be the answer. Any questions on that? All right. So we have some of these on the back. I'll do the first one with you and ask you to, at your table, divvy up and do like 2 or 3 each. So our first one, we're supposed to divide and write the remainder over here. So this one has x equals -5. So I have 1, -18, 60, 25. By the way, what if I were missing one of those terms? What do I need to put in? 0. Some of you saw that on the worksheet. Okay. So this is -5. -18 plus -5 is -23. Times -5 is 115, so 175. Times -5 is -575, which gives us negative 550 for our remainder. And all they want is the remainder. So I don't need to write out what's left, what is the actual quotient. I don't need that, I just want the remainder for now. So try that for the next 5 problems. You should each do at least 2 of them. At your table, you could each agree on doing certain ones that we can compare to each other. Not everybody has to do every one of them. Take a minute to do that. Real quick for the record, what did I do? 175, right? That was right. Times negative 5. I multiplied wrong. This is negative 875, which actually gives us an answer of negative 850. That was my mistake. I just multiplied wrong. But guess what you should have gotten for all the rest of them? 0. They all got a remainder of 0. Gee, what does that tell us about these divisors? They are what? They're perfect. Well, it actually tells us 2 things about them. If they divide in perfectly, just as 2 divides in perfectly into 6, then they are what? A factor. They are a factor of the polynomial expression. And also think about this. X equals 5. What would the output be if I plug that 5 in? If I plug 5 in, I'd get an output of 0, which makes that what? It makes it one of the zeros. So not only is this a factor, but this is also one of the zeros if we were to graph the function. Okay? So you guys all got 0 for those, right? No? All right. Which one didn't you get a 0 for? 4th one? So 1, 2, 3, 4. The one that's x cubed minus 2x squared? Okay. So I got 1, negative 2, negative 13, negative 10. And I got to put negative 2 in the box because I set that equal to 0. Bring down my 1. Multiply it by negative. It's positive 8. Negative 5 times negative 2 is positive 10. By the way, all of these were cubic functions. What's left when I divide out that one factor? What type of function is left here? A quadratic, which I could either solve by factoring or solve by quadratic formula if I needed to. Gentlemen, that brings us to this, the factor theorem, which we've already talked about a little bit, but not completely. Polynomial f of x is a factor, has a factor x minus c if and only if f of c equals 0. So if and only if the remainder is 0, because remember the answer to this is the remainder. Synthetic division and remainders, there's some rules about those. We've talked about those before. What we're looking at today is determining if these are factors, and then we're going to use the binomials that are factors to write out the factored form. So we're going to factor it completely if it is factorable. Okay? Do I expect you to do synthetic? If I give you 5 different factors, do I want you to do synthetic division 5 times? No. I want you to use your calculator. You don't have time for that. We have other stuff to do. And as we get to bigger problems that involve this as a step in like the 10-step process, we're just going to use our calculator to help us identify them. So I'm putting in this function into my calculator. I think it was almost better with the light. I put this function into my calculator, and I go to the table, and I'm going to put in 5 and negative 5. And I'm going to write down next to those factors what the remainders were. For negative 5, I get a remainder of negative 850. So that is not a factor. For this one, I get a remainder of 0. So this is a factor. Knowing that that is a factor, I'm going to write it down here as part of my final factored answer. I don't want to forget about it. And I'm going to put in, since I'd set that equal to 0, I'm going to put 5 in the box and actually divide away that factor to get the quadratic that remains. Remember to put in 0 for any terms that are missing. On all of these examples, though, there are no terms missing. Bring down our 1, multiply. Add vertically, multiply. Add vertically, multiply. And sure enough, I get a remainder of 0. In fact, some of you did this one already, right? Doesn't this one look familiar? This gives me, remember, this is my remainder constant x squared. I expect 1 degree less than what I started with if I'm dividing out a linear binomial. And so I end up with x squared minus 13x minus 5. And I would try to factor that further and list all 3 factors, but this one is not factorable. Okay, if you did the discriminant 13 squared or negative 13 squared minus 4 times 1 times negative 5, it says it is factor. No, it's not factorable. It's 189. So those 2 are going to be real answers, but they'll be irrational. So I'm just going to leave this as my answer. I can't factor it any further unless I find the zeros. All right, for our next one, it's also a cubic. And I'm going to be testing x minus 5 and x plus 2. So I'm going to plug in x cubed minus 2x squared minus 13x minus 10. And I'm going to plug in 5 and negative 2. It turns out that both are zeros. So I just have to find the third factor. So this one should be factorable. I'm going to put both of them down here, but this is the one I'm dividing out right now is the x minus 5. 1, negative 2, negative 13, negative 10. I bring down the 1 and multiply. And again, I get a remainder of 0. This also should look familiar. Some of you did this equation already. So this is x squared plus 3x plus 2, which should be easy to factor. But I already know that x plus 2 is one of those factors. It's x plus 2 by x plus 1, multiplying to 2, adding to 3 in the middle. So this has been completely factored by finding at least one of them to be a 0 or a factor and dividing it out and then factoring what was left. Try this for the last problem. Determine if the 2 that are listed are or are not factors, and then try to factor that. I'll be right there. All right, so we synthetically divided. This is what we were left with. We factored it. One of the factors was already given up here. At this point, you're asking for the learning target, can I use the factor theorem and remainder theorems? So can you divide them out, determine if it's a factor, can you factor what's left? The assignment is down here. The review assignment will help you, but it's the same review as Friday, so if you already did them, you did them. But this is the required part for reassessment purposes.